the function is defined by two different expressions in two different parts of the domain, and we need to find the values of a and b for which the function is differentiable. The first condition that has to be met is that the function is continuous on its whole domain. It's obviously continuous both in this part of the domain where x is less than or equal to 0, and in this part where x is greater than 0. However, it needs to be continuous also in the point where two piecewise definitions of the function meet. Therefore, it has to be continuous at x is equal to 0. So, the value of the function at x is equal to 0 must be equal to the limit where x goes to 0 of the value of the function. This limit is actually the right-hand side limit, so x goes to 0 from the right-hand side, because the limit defines the value of the function as x approaches 0 from the right-hand side, while the exact value of the function of x is equal to 0 is defined by this left-hand side expression. So, x squared plus x plus a at the point where x is equal to 0 must be equal to the limit where x goes to 0 from the right-hand side of bx plus 2. That leaves a is equal to 2. The second condition is that the derivative is continuous and bounded in the whole domain, and that includes the point x is equal to 0. It's quite obvious that the derivative in the rest of the domain, excluding the point x is equal to 0, is both continuous and bounded. However, we need to test the condition at x is equal to 0. So, derivative of x at x is equal to 0 must be equal to the limit of derivative of x as x tends to 0 from the right-hand side. Once again, we use the fact that at the point x is equal to 0, the left-hand side expression defines the value of the function, while the right-hand side expression defines the value of the function as x approaches 0 from the right-hand side. So we have 2x plus 1 at x is equal to 0 must be equal to b. That leaves us with b is equal to 1.